Today we're going to be continuing on with our discussion of pollution. And mostly today we're going to be focusing in on the issue of solid waste. But we still have a little bit of review to do from last time concerning water resources. So why don't we start there? If we go back and think about where we ended up last time, talking about how it is that wastewater can be treated. We mentioned a number of different sorts of water purification kinds of steps that can be taken. And by and large, I'm talking here about what goes on with municipal water systems, where wastewater from houses and industries and so on enters a larger system that treats an entire community. So, in this kind of a situation, we saw that water can be put through a number of different steps, like primary treatment to remove solids and secondary treatments to remove some of the organic materials, and then even tertiary treatments to clean up some of the rest. And one of the final stages would be to chlorinate the water, to put in a chlorine compound to kill bacteria. Although, as I mentioned last time, ultraviolet irradiation is also an acceptable way of dealing with bacteria in water. Several additional kinds of things that can be done include things like the addition of aluminum sulfate as a final kind of a treatment option, which can get rid of some of the turbidity in water by precipitating out these things that cause the turbidity. Still, another kind of a thing that can be done is to filter water through activated charcoal. And this can be done at a municipal level, but often also individual homes can have activated charcoal filters put into their water system. And what that does is it helps to filter out certain of the organics from the water. So now let's turn to the main event for today, solid waste. We could divide up solid waste into coming from two principal sources. Municipal waste, which is the kind of trash you generate in your own home, which gets collected by municipalities and trucked to a disposal site of one type or another. Although increasingly, and you've probably seen this in your own community, more of the trash that your house generates gets separated into recyclables. Recyclable paper, recyclable glass, and also plastics, as well as metals. So a lot of the things that we put into the trash we can instead be recycling. And in addition to that, what a lot of people do is they don't put any food wastes in their trash, especially vegetable wastes. Instead of putting that in their trash, they compost it and use it in their gardens. So in my household, no vegetable waste goes into the garden. It all gets composted for our agricultural operation. It's part of the process of farming organically, is to get your nutrients from things other than mineral fertilizers. Now, actually, however, most solid waste doesn't come from municipalities. It comes from things like industrial processes and mining, and also agriculture. All these can produce large amounts of solid waste, which then need to be dealt with one way or the other. In some instances, these materials can be recycled. In other instances, we're dealing with toxics, especially from certain kinds of chemical industrial processes, and they have to be dealt with in a different kind of a way. Here's a government-generated graphic that illustrates the relative proportions of materials in solid waste. So you can see from this graphic that many of the substances within solid waste can be recycled. A third of the solid waste is just paper. That can certainly be recycled. Wood could be composted. Certain of the organics, like food residues and things like that, can be composted. Metals can be recycled, reused. Plastics can get recycled, glass. So in recent years, we've worked towards greatly reducing the amount of stuff that we actually put into landfills by recycling much more than we used to years ago. Now, despite all that reusable stuff in our solid waste, this is an EPA generated graphic that illustrates what we actually wind up doing with it in the USA. More than half we still throw out. Another third or thereabouts we recycle, and a little sliver we use to convert back into energy at what are called trash to energy facilities, where we can burn the trash and then use the energy derived from that. Here's still another EPA graphic that shows us in a different way what's been happening over time with solid waste. If you look at the blue line, that is a measure of how much waste is produced every year. So this shows a trend over a period of about 50 years. And so the amount of waste produced has gone up over time, but in the past 10 years or so, it has pretty much leveled off, which is an interesting phenomenon. Let's relate that to the lower line, the orange line. That's the per capita production of waste. And notice that although it has gone up over the past 50 years, for several decades now, it's been pretty much flat. So we have gotten some control over the amount of solid waste we've produced in the US. Now, all that stuff that doesn't get recycled or turned from trash to energy, all that stuff has to be dealt with. And traditionally, what's been done with it is it has been put in a landfill. One that is a properly run facility is generally called a sanitary landfill. So these are places where solid materials are covered over with layers of soil. And so over time they tend to develop this mound shape. Modern landfills, before they start filling up with solid waste, are usually underlain with a plastic liner, an impervious material that substances in the solids can't leak through. Now, although we still use these landfills to discard of solid waste, many of the old landfills have now been filled up and are capped over, and it has become much more difficult to site new landfills. There tends to be lots of local opposition to siting landfills in a neighborhood, in a locality, but there are also much more stringent environmental regulations that new landfills must meet. Now, despite that, we still do use landfills, and they are used over a period of years until they fill, and then they are capped off. And once they're capped, they have to be monitored for a series of years afterwards, because many of the solids in the landfill will decompose over time, and as they do that, they will emit methane gas. So typically a capped landfill will have white plastic pipes coming out of it at intervals, and these white pipes will then have an elbow on them pointing down, so that the methane gas can be evolved out of those underlayers without rainwater getting down into those pipes. Now, despite the fact that these landfills are now underlain with a plastic liner, these plastic liners are not infallible. They can tear, and if they do, pollutants that are being held up above them can leak through, and in that case they can get into the groundwater. Here is another government-generated graphic that illustrates how a modern landfill is configured. Notice that there's a preference for siting these landfills in an area that is underlain with clay, because clay is very impervious. And then over that, another layer of clay can be placed and compacted to make it still more impervious. Then we can have some kind of a plastic membrane on top of that to further impede movement of materials out of the landfill. There is also often a sand gravel drainage layer so that liquids that drain out of the landfill can be recovered and then dealt with in other kinds of ways, especially if there's toxics in them. And then over that you have the layering of waste and soil. Here we have a different government-generated graphic that illustrates a variation on a theme on how these landfills can be layered. Notice in particular on this one, this is a landfill that's been capped. So over the waste material, notice there are a series of additional layers. Notice that there's a layer of stones, and then capping everything is a layer of soil, a thick enough layer so that vegetation can be planted on it. And exactly what kinds of plants get put in can vary depending upon the goal. There are plants that can be put in that will actually help to absorb or break down some of the remaining toxics that might be present. Although often, after a landfill's been capped, they're simply seeded to grass, which is then mowed periodically. Now let's turn our attention to the topic of incineration. This is an option which is available for lots of kinds of solid waste. They can be burned, and then the energy that's released from burning them can be used as an alternative to burning other kinds of fuels like fossil fuels. So there are plants called trash to energy plants that are constructed that do just this. So they have a number of advantages. You're actually deriving something useful out of a waste product, and you're also greatly reducing the amount of solid waste that's present. So that means that we don't fill up landfills with this stuff so rapidly. And then the product of this incineration, this greatly compacted stuff, that can be sent to a different kind of a landfill instead, in what's called an ash landfill. There are, however, some significant disadvantages to this kind of a process. And that is that by combusting waste, certain kinds of toxic chemicals can be released. One of the ones that trash to energy plants have had an issue with is dioxin, which is an exceedingly toxic substance that even in small doses can produce cancers in people. The other issue would be the ash itself. The ash itself can be rich in toxins as well. And so when it is disposed of in an ash landfill, special kinds of precautions have to be taken in order to keep that ash and its toxins from moving elsewhere into the environment. Here is a graphical representation of a typical kind of an incinerator. So we have waste materials stored until they are fed into a furnace, and then as the material is burned, the heat from that burning can be used to boil water. And the steam that's generated can be used either to heat buildings, or it could be used to turn a turbine and generate electricity. Waste from the furnace, the ash can go to an ash landfill, and also things like metals can be recovered and recycled. Now, gases generated by this furnace operation can then be cleaned through scrubbers and electrostatic precipitators, those sorts of things. Ash from that cleaning can go to an ash landfill, and the water from these processes can also be treated before it's released back into the environment. And the gases, after they've been cleaned, they can be released. An alternative to incinerating the organic components of solid waste is to compost it. And some municipalities will do this. Large agricultural operations can do this, even small ones like this little farm you see right here. This is part of my little farm, in fact. And I compost quite a bit of plant material every year, along with chicken manure and chicken bedding and things like that. It all gets composted. And there are various kinds of approaches to composting. There is what is called hot composting, which is generally done in some kind of an enclosed structure, so that you layer plant materials with dried plant materials like straw, and also with layers of soil. And this enclosed structure keeps the heat of decomposition from bacterial action on this stuff quite high, generally in the range of 160 degrees Fahrenheit. And this promotes rapid decomposition of the materials that are in the compost pile. And it also tends to kill pathogens and insect pests and things like that. So it's a good way to compost materials that one wants to reuse in, let's say, an agricultural operation. Now, I actually don't do that. I do something called cold composting, which is basically just piling up stuff. Although even in my compost operation that is just a pile of stuff, I still do layering. So all the corn stalks from all those corn plants you see growing in the foreground, every spring I take all those corn stalks and they form the bottom of my cold compost pile. All these carbon-rich materials get put on the bottom. And then over them I take all of my assorted clippings and weeds and all these green sorts of things, and they all get piled on top. So that would be nitrogen-rich materials. And then a lot of soil gets mixed in the roots of weeds and things like that that I throw on there. But instead of enclosing it, I just make a giant pile. And even though it's not enclosed, it still does get rather hot. So I can recall instances of sticking my hand inside the compost pile for one reason or another and getting my hand burned because it was really quite hot. Even in the dead of winter, the cold compost pile can still be quite warm in the center of it. Warm enough that often what I'll see happen is that snow gets melted off the compost pile in the wintertime from all that heat escaping. Now, cold composting is not as good at destroying pathogens, although it actually still does do a pretty good job of that. One of the keys is to turn it over every year like I do, starting with a new base, and then letting it sit for a long time before I actually use it. So that's quite a bit of time is spent in that decomposition process, so that by the time I turn it over again, all the stuff on the bottom is ready to go right back into the vegetable operation. It's very nice looking black soil kinds of stuff that comes out of that. Here is a photograph that shows my cold compost operation. In the springtime, this pile is a good 6 feet tall by about 10 feet wide. So it's a fairly good sized pile. But yet by the end of the growing season, that 6-foot pile has decayed down to about a 3-foot pile. And that's about what you're looking at here. All the green kinds of stuff and brown kinds of stuff that you see sticking out of the snow, that's all stuff that I put on over the winter. That's all chicken manure mixed in with chicken bedding. Although even after it snows, the snow does tend to melt off this stuff pretty quickly because of the heat that's being generated by all that bacterial decomposition. Other forms of waste reduction, in addition to incineration and composting, involve recycling. And the U.S. is getting increasingly better at recycling. We have historically been a nation of throwing things away, the throwaway economy, it has been called in the past. But that kind of thinking is changing for a number of different reasons, and not just conservation related reasons, but economic reasons as well. And of course, we've talked about the fact that nobody wants a landfill in their backyard. It's very hard to site new landfills, and so the pressure is on to reduce the amount of waste we produce. And many of the things that we have traditionally thrown into landfills are eminently recyclable, like glass and metal and paper and wood, and even plastics of many kinds can be recycled. Other kinds of things that can be done is at the source. Things like fast food restaurants used to be famous for over-packaging things with a wrapper inside of a plastic box, inside of a bag, and the pressure has been on them, among other kinds of industries, to reduce the amount of packaging that they put things in. Therefore, there is less stuff that needs to be dealt with after consumption. This is a very nice little EPA generated graphic that illustrates present thinking about what to do with solid waste. We start out at the source where waste is generated, and then a component of that can just simply be reused. What can't be reused directly can be recycled. And another alternative that we've seen is that it can be composted. Things that can't be recycled and composted, those we can send to incineration, and we can recover some of the energy out of them. And then the stuff that's left over after all that, is relatively small component of all the waste, and that's the stuff that we, in the final step, have to either treat or somehow dispose of. Now, we've been talking about various classes of wastes that can be toxic, and so let's focus in a little bit more on them under the heading of hazardous waste. These tend to be highly reactive kinds of things, corrosive things, or other kinds of things that are poisonous to living organisms. And quite a few kinds of human activities generate these things, from industrial processes to mining to things that we do right around in our own households even. And so when we produce these things, they are dangerous for humans and livestock and other kinds of living things to be exposed to. And so they need to be dealt with. And Congress has passed legislation that helps to deal with some of the issues that arise from hazardous waste. One important piece of legislation is the Comprehensive Environmental Response Compensation and Liability Act. This is known more commonly as the Superfund program, and it deals with sites that have become poisoned to a substantial degree and need to have a major cleanup operation that can address the toxins that are present. And part of this act actually compels the people who did the polluting to clean up and foot the bill for their poisoning of a particular location. Here is an actual photograph of an EPA designated Superfund site in the town of Uxbridge, Massachusetts. There are Superfund sites like this all over the country, but this is one that I happen to have a photo of. This is an old thread mill, and during its years of operation, it's now closed, but during its years of operation, textile kinds of industries were famous for dumping poisonous materials on their property and dumping poisonous and other sorts of bad things into rivers. And a river went right through this, and you can see that in this photograph also. This was not one of the worst of the Superfund sites, but it still was significant enough that it had to be dealt with. So let's consider some of the classes of hazardous waste. What we're looking at in the background here is a capped landfill, by the way. And notice that it's got grass growing on it. And native grass, in fact, little blue stem grass, which is a native prairie grass that actually extends over much of the continent. So classes of hazardous waste include carcinogens, and I've already mentioned dioxins as being one of these things. Toxic metals, things like cadmium, mercury, lead in particular, are hazardous wastes that are released from things like burning coal and various kinds of industrial processes. They're present in things like rechargeable batteries, and so when people throw their rechargeable batteries out and they make it to the landfill, cadmium will be present in the landfill and can leach out. Another substance would be arsenic, which is kind of like a metal. Chemists refer to it as a metalloid, but it's really not quite a metal. And this stuff has been used for a variety of different kinds of purposes over the years. Different kinds of industrial processes require it. It was once an agent in pesticides. I can remember using this pesticide called lead arsenate, which was just wickedly toxic stuff. It was a fungicide, and it worked very nice at controlling fungus, but then you poisoned the soil. So it was not a good choice for agricultural lands. And it was once used with copper as a substance to act as a wood preservative. So if you went to the lumber yard and bought pressure treated lumber, that's what it was treated with. That's no longer the case. Copper compounds are still used because copper is very good at preventing rot, but it's not used in conjunction with arsenic anymore. Although copper itself in high enough concentrations can be a bad thing for plants and animals to be exposed to. Other classes of hazardous waste include things like biological waste from hospitals or doctors' offices, things that can have infectious agents in it. They are usually collected in sealed containers and that are then incinerated or somehow or other made no longer hazardous. Pesticides is another big class of hazardous waste, especially the persistent pesticides, the chlorinated hydrocarbons, which have been largely but not entirely phased out. There are still some uses of some of the chlorinated hydrocarbons that are permissible, but because they have a very long time of persistence in the environment, they can be quite dangerous things. DDT was one that was used in the World War II and post-World War II years, and although it itself was not all that toxic, I mean, you could eat a spoonful of it and it wouldn't kill you, but its sublethal effects, its effects on physiological processes, things like that, was dangerous enough that it was phased out of use. We'll talk more about persistent pesticides later. But other classes of pesticides, like the organophosphates, which break down, most of those break down rather rapidly, they still are quite toxic to be exposed to. They are neurotoxins, and so people who are exposed to them in the course of using them in agricultural operations can get quite ill and even die from using them. The persistent pesticides had a history of being more insidious, however, because for years after they were used, they would remain in the soil, and sublethal effects from their presence in the environment caused a number of sorts of issues with public health and animal health. Other classes of hazardous waste include things like the polychlorinated biphenyls, which are toxic chemicals that were once used in things like transformers as an insulator. Although they had other industrial uses as well, they're another group that's been largely phased out of production. They were released into the environment from the plants that manufactured them. They were released into the environment from leaking transformers and things like that. They tended to accumulate in aquatic systems and things like that, and again caused a host of sublethal kinds of problems, metabolic, physiological problems in different sorts of animals. Chlorofluorocarbons are still another class of chemicals that's been now largely phased out. Not everywhere in the world, but most places they have been phased out of use. They were used in aerosol cans, but as they traveled into the upper atmosphere, they had negative effects on stratospheric ozone. And we can finish by mentioning organic solvents and radioactive materials. But on that note, we'll end this rather long program for today.